Okay, now that we've done volume, let's switch it up and let's go to surface area now. All right, and so now they're going to have to find the surface area of this using that same one. So we're going to write one expression for a of x by summing the area of all five faces. Okay, and so first, let's get that side out of the way. Okay, and so when we have this, all right, we're going to have a 2x because that's going to be one of the lengths of the side because, again, that's what we're folding in. And then in that would be the 11 because that's how long it is, minus the 2x because that's what we're cutting out. We're cutting those two squares out of our box. Okay, now since it's surface area, now we've got to add it with the width. And so again, I'm going to have a 2x. All right, the original size of our paper was at 8.5. We do have to subtract the 2x from those as well. Okay, and now we've got to also have the area of the bottom of our box, the big side, and so that's going to be that 11 minus 2x times the 8.5 minus 2x. Okay, and so that's really what our box is in a nutshell. Okay, and then if we're going to find another expression that we could use for the cutouts, you know, when we have a of x here, really if we're going to simplify it down, it's just that 11 times 8.5, which is our normal sheet of paper, because we know that that's the surface area of the paper that we're using, but you got to subtract the 4 pieces that you cut out. And so that's why it's 11 times 8.5 minus 4x squared. And I guess let's go ahead and throw some parentheses around this 11 to make it look good. Okay, so there we go. All right, let's not worry about that. That would take too long. I want to get you moving. Okay, so to cool down with this part, you know, we see that our paper, if we're using paper from overseas, this A4, it's 21 by 29.7 centimeters. And so you can see the equation they use. Again, the minus 2x is just showing that that's the 2 squares that you cut out. Okay, and it's asking what would be a reasonable domain. So what would be a reasonable x value that we could have, okay, and doing this. So again, if your paper is 21 inches wide, okay, and you're taking chunks out of it, it's not like you cut a 20-inch chunk out of each side. The paper's not long enough. And so really it just comes down to, okay, what would allow me, you know, for a reasonable amount to be able to take that square out and still be able to fold it. And so what we're looking here is probably x needs to be, x, we'll use the equation. So really x needs to be less than 10. And that's really what we're looking for. Any number less than 10, because we have that, then it's at least 21 minus 10. So you do have 21 minus 2 times 10, which is 20. So you at least have 1 inch to play with. But yeah, so your domain would really be anything that's 10 or less. And this gives you a good example explaining it as well. Okay, here's a summary of the lesson. So if you're still struggling, we did the virtual, or we did the audio. If you are a visual person, this would be good to jump back on slide 16 to talk about what we've had. All right, so now you're going to see what do you notice, what do you wonder, just a couple different things to have. All right, they use 300 plus 20 plus 9 to get this 329. This is what we're used to. We also can group it with these 3 100s, 2 10s, 9 1s, and even more so, you know, if we're trying to find that area, hey, it's 3, and this is 10 squared, 10 times that. This is 10 to the first, and it's 10 to the 0 power, all right? And so just 3 different types of ways to write that. Okay, we get to evaluate. Again, let me get a new sheet of paper here. Don't mind this blue background. It's just my daughter's gymnastics. I'm in the basement here, so I've got to use whatever I can to write on. So if we have P of X equals that 5x cubed plus 6x squared plus 4x, Again, if I'm evaluating that at -5, that means I'm plugging a -5 in for every single x. Now just make sure when you do plug that in, it looks like this. Okay. Because again, if you don't do that with your negatives, you'll get the wrong answer. Okay, you'll get the wrong answer. So let's just go here, let's use our calculator, and we're just going to plug it in right like I have it listed right over here. So 5 parentheses -5, okay, cubed plus 6 -5 squared plus 4x. Oh, I didn't put, I'm sorry, this x here, I should have caught that. That's a -5 as well. Okay, and so now we get a negative 495. If you hadn't put that negative in there, let's see, by the way. Nope, we did it right. Okay, now 15. 15, we're gonna do the exact same thing. All right, I'm gonna have the 5. We're gonna put the 15 in there. We're gonna raise it to the 3rd power. We're gonna add it to 6. Put a 15 in there again. Raise it to the 2nd power this time. Plus 4, and again that 15. And now we've got 18,285. Hey, all right. Okay, and so now we know how to evaluate, and it's asking you, how do you, how does knowing that 5,000 plus 600 plus 40 equal that, okay, help you solve the equation? It's just to getting in that mindset of knowing that, hey, that's the same thing as saying, like, that's 5 times 10 cubed plus 6, 10 squared plus 4 to the 10th. I mean, that's really all we're doing there, okay, to get that 59 or 5640. And so now we come here and we see, all right, what's the meaning behind the point of the intersection of these two graphs? And so we see a y equals line, a horizontal line here, and then we see this nice polynomial coming up. Okay, what does that mean? And that's just the point of our intersection, all right? So we're evaluating. So again, we're evaluating whatever that polynomial was, this 5640, okay? We're saying that when x is 10, it's at 5,640, okay? So there's your input into the expression or the function, and there is your output. Another video explaining. All right, and so then we notice here that Han notices, he says that 11 squared is 121, and x plus 1 squared is x squared plus 2x plus 1, okay? Does this hold true for the 11 to the 4th and x plus 1 to the 4th? With those, it actually does. If I've got room here, 11 to the 4th is 14,641. And if we were to multiply that out, the x plus 1 to the 4th, you would get that same thing where it's x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. You would still get that same model. However, when it's 11 to the 5th, okay, now we're talking that's, let's see, 11 to the 5th is 161.05. And actually there's a 1 at the end, so 161,051. And what happens is when we try to multiply that out, it just doesn't, that mirror image doesn't take place. Our numbers are getting too big. We're having ones carry over. And so there we go. Okay, and so now let's go to the next one. All right, we're going to talk a little bit about interest here. This is a little bit of fun. And so now I've got, at the end of 12th grade, Claire's aunt started investing money for her to use after graduation from college 4 years later. The first deposit was $300. Annual interest rate of the account. Then at each school year, the balance of the account is multiplied by the growth factor. Growth is x equals 1 plus r. After 1 year, total value is 300x. After two years, total value is that 300x times x, so you get the 300x squared. Okay, write an expression for the total value after the graduation in terms of x. Okay, so that is easy, easy. All right, we can call it whatever we want. Let's call it the Claire function. So we've got c of x here equals, all right, and again, we know that she starts with that initial investment of 300x. That's 9th grade year times 10th grade year. She doesn't bring anything else. All right, oops, messed up here. Make sure you guys can still see that. Sorry, I'm looking down. Here's another x after 11th grade year. All right, and here's, I did it again. Golly Moses. Here's another x for the 12th grade year. So when we multiply that out, it is just 300x to the 4th. Okay, 300x to the 4th, because again, it's multiplying on that, and you've got 4 term years. Okay. So now we see here, okay, the first deposit was 300 interest rate. Then at the end of each school year, it multiplied by the growth factor. If she invested another 500 at the end of the freshman year, what would the expression be? Okay, and so now we're looking here, and let's see if I'm gonna get another sheet of paper. Okay, so we know that we have the 300 x to the 4th, right? We know that. But now she added another 500 at the end. So now we've got, okay, times the 500, or I'm sorry, not times, but the plus the 500 that we added after the freshman year, and that's going to grow for 3 years. So now we know that this now is going to be 500 x cubed. So let's call this, again, the Claire function. So c of x here equals, okay, you have your 300 x to the 4th, and then you're going to add the 500 that are growing, and that's growing for 3 years. Okay, and so now that is our new function. Okay, in terms of that, because it's only growing for 3 years because it was after her freshman year. And then there's another video helping explain it. Okay, now you see here the first deposit was 300. Then at the end of the school year, the balance of the account is multiplied by a growth factor of that. The total amount after 4 years is a function of c of x, the growth factor of x. If the total amount that Claire receives after graduation is, 1,580, use the graph on the next slide to find the interest rate that the account earned on the record below. Okay, so now we see this, and you can see here. Here's the next slide. All right, what we had here, and that it's kind of going on other things, but again, what we're going to say is, okay, we want this to be 1580. Okay, we want that to equal it. And so what we have is we have this whole c of x, and we're going to go ahead and use this equation right here. So this 300 x to the 4th plus 500 x cubed, and I forgot to put an equal sign here. Okay, and so there is our account. Now you can see here, if it was just the x to the 4th, it's over there. But now we've got here, we've got to add that 500 she so willingly gave us after our freshman year, and it looks like this. So, okay, again, I'm coming here and I'm saying at 1580, it's a 1.2217. Okay, let's write that down to figure out what that interest rate was, okay? And it's going to help if we go back to the next slide. And so now here's what I've got. Okay, now we say, now, you know what, I'm going to go back. It says to go forward, we're going to go back. When I do this, remember, it's 1 plus the interest rate, okay, as a decimal. So right here, we want to find the interest rate that account earned and record below. You're just taking this minus the 1 that it asked us to subtract or to add in the first place in the formula here. So now I've got 2217. I've got to convert that into a percentage. So you move the decimal places, and that's 22.17%. Holy cow, I wish I had something that grew that great. Okay, so there you go. All right, so now we go here and we say that this is currently invested in the account. X is the growth rate. Again, we go on this, remain annually. How long ago did the account open? This is just being able to look at this and acknowledge. We see here the first, the leading term here, or the power of the polynomial is 15, so x to the 15. So that means how long did it open it? 15 years ago. Because we know that each year it multiplies on itself. And so 15 years ago will be how long it's open. Okay, how can you tell that the last time money was put in the account was $300 and it was 2 years ago? It's the last term in this polynomial. And so we had 200 that was 15 years ago, 100 that was 14, 500 that was 5 years ago, and it was 300 that was 200, or I mean was 2 years ago. It's squared, so it's been only multiplied by itself twice. Suppose that 300 was deposited in the account 8 years ago. How would you need to change the equation? Well, we write polynomials in descending order, meaning we start at the x to the 15th, work down, okay? And so what that now would look like is 200 x to the 15th, all right? It won't, can't see it there, so let's do it right here, okay? So we're gonna have the 200 x to the 15th, okay? We're gonna have the 100 x to the 14th. Now is where I'm going to slide the 300, and again, this would be x to the 8th now. Then you have your 500 x to the 5th, and your 300 x squared. Alrighty? Perfect. And now that we say the interest rate is 5%, and we want to calculate C of x is, we're putting values into the calculator, find it. What might go wrong? Now again here, we're taking it and we're plugging it into these x's here, okay? What that rate is, there's a number of things that could go wrong. First off, you could be just putting it in as a 5. You could be putting it in as a 0.5, but we all know that that percentage as a decimal is 0.05. And it says x is 1 plus the interest rate. So we got to add 1 to that. So it's 1.05. So you're going to be inputting 1.05 into every single x in the function. Okay, and that would be how you would find it. All right, there's a video helping explain. Here's our cool down. All right, what is the total amount in the account? The interest rate was 3% each year, round to the nearest dollar. So let's go ahead and get our calculator out. We've got 800. We're inputting that 1.03 in because that is our interest rate. Again, it's 3%. 3% is a decimal, is 0.03. We're adding it to 1.03. Raise it to 4 plus 350. I'm sorry, don't raise it yet. That'd be incorrect. Take that 1.03 in parentheses, raise that to cubed. Okay. Now plus 500, 1.03, square it, and then plus 600, 1.03. Okay, so there you go. We're raising it to the nearest dollar. It's 0.3, so it's not going to round up. And so I'm looking at $2,431. Okay, how much money was put into the account at the beginning? How do we know that? Hey, 800. 800. It's the one that's got it's our leading coefficient right here. Again, numbers in front of the variables are called coefficients. This is my leading one. It's tied to the highest power. After 5 years, $200 is added to the account. Use the expression for A of X, write a new expression, B of X, that represents how much is in the account after five years. Okay, and so now you would just be doing the same thing. I'll let you practice there on your own, but again, you're going to be putting so then after 5 years, everything would bump up. So here, we'll just go ahead and do this really quick, and then you can be on your way. B of X equals, now since it's 5 years, it's going to be X to the 5th plus 350, X to the 4th. Oh, shoot, forgot my X. X to the 4th plus 500, X squared. Oh, this is the 3 now. Sorry about that. Plus 600, X squared, and then plus the 200 that was just added to the account. Okay, and so there we go. Lastly, here's just an overview of the lesson we did today. You'll find that on the last slide, and that's part of it. And then you have your edge elastic today. I know this video is long, but you can pause it, you can move forward and so forth. I hope it was helpful. And if you have any questions, feel free to zoom in. I believe I set that time as 2:15. So, all right, have a great day.